In this video, which is titled Right Triangle Trigonometry, we're going to learn about the 6 standard trig functions. And we'll be using these functions for all the trigonometry that we do in here, and you'll use them for all the trigonometry in future classes and so on. There are other trig functions out there. We will not talk about them in this class other than these 6. And I've never personally seen them used, but I've heard that some specialized fields will actually use other ones. So the 6 that we are going to talk about is sine, cosine, tangent, cosecant, secant, and cotangent here. And we're going to start out by defining what these are based on a right triangle. So the idea is you're going to have a right triangle. In this case, I used the standard 3, 4, 5 right triangle you've probably seen before. And I'm going to call this angle down here theta. Now we could try to measure, we could try to find out what number that angle is, in degrees or radians or so on, but I'm not going to actually worry about that because we're not interested in the angle as much right now as we are interested in the trig functions. And so if I wanted to find out, so remember a trig function is a function, so it's got input and output. So the input is the angle here. And based on the rule I have up here, I'm supposed to take the side that is opposite the angle and divide it by the hypotenuse side. So the side that is opposite the angle theta here, that would be 4 is opposite, divided by the hypotenuse is 5. And so that means sine of this angle is 4/5 or 0.8. If I wanted to do cosine of this angle, it would be adjacent side over hypotenuse, and the side that is adjacent to the theta is 3 over the hypotenuse is 5. And thirdly, we want tangent of that particular angle is opposite over adjacent here. And so the opposite side is 4 over the adjacent side is 3. So tangent theta would be 4/3. Now, there's a quick way to remember these rules here when trying to find sine, cosine, and tangent, and that is SOHCAHTOA. And so SOHCAHTOA stands for sine is opposite over hypotenuse, SOH. SOHCAHTOA, C for cosine, adjacent over hypotenuse, CAH. And lastly, the TOA part, T tangent, is opposite over adjacent. And so if you remember your SOHCAHTOA, then you remember which angle is which on this triangle, and you're good to go. Now you might be wondering, well, how am I going to get the other 3? There's no second SOHCAHTOA thing to help you remember that. But you have to remember that the 3 of them are what you need from the triangle, and the other 3 are going to be the reciprocals. So for example, the cotangent is going to be the reciprocal of the tangent. So instead of 4/3, it's 3/4. Now it could be easy to mix up the other 2 here for which one's secant and cosecant. The way I always remember it is that in these reciprocal pairs, one is going to be a co and one's not going to be a co. So since I already have my co and the cosine, the reciprocal is going to be just secant without a co, and the reciprocal of 3/5 is 5/3. And then since I do not have a co for sine, I will have a co over here for cosecant, and it's the reciprocal 5/4. Okay, so this is how we find trig values based on a given right triangle. Now with that said, we can prove certain things called identities, and I think it's very important to know what an identity is because it's different than an equation. So an identity, these are equations that are always true. So think back to algebra and think back, solving equations. If I ask you to solve x squared equals 4, you can give me the answer, right? You can tell me what x is equal to. But the thing is, x squared equals 4 is called a conditional equation. It's valid, it's true for some x, but it is not true for other. Try plugging in x as 1, it's going to be a false statement. The difference here is that all of these identities, these are always true no matter what your angle is. So for example, cosecant is always the reciprocal of sine no matter what. That's why identities are great, is because they work no matter what angle you're talking about. It's not going to change from problem to problem. Next, so we have the three reciprocal identities here. Then we have the what are called quotient identities, because you're dividing things. Tangent is the same as sine divided by cosine, and cotangent is the same as cosine divided by sine. And then the last identities, for now at least, there will be more in the future, are what are called the Pythagorean identities. And the one that you really need to know is sine squared plus cosine squared of the same angle always gives you 1. And you will use this identity so many times in your mathematical career. I would not be surprised if you used it more than 1,000 times between now and getting your degree. That's how common it is. You will probably use it already 100 times or so just in this class, but every time you go on, they're going to keep using it over and over again. It's incredibly common. So if you're going to memorize nothing else on this page, at least memorize that sine squared plus cosine squared for the same angle always add up to 1. Now let's use that to answer the last question here. It says we know that we have a triangle where the value of sine is 2/3. So if I draw my triangle here, it's going to be a right triangle. And I got my angle theta here. And I know sine is 2/3. And I know sine is opposite over hypotenuse. So I would have opposite over hypotenuse there. Now I do want to kind of point out something. We could have actually had a different triangle here, because all we know is that the ratio is 2/3. So for example, you could have had 4/6. 4/6, when you simplify it, it's still going to be 2/3. It'd still be valid. But we might as well use nice smaller numbers, because it'll make the rest of the problem easier. And since we're going to be doing ratios anyways, it doesn't actually matter, since we're just looking about trig functions. So that's ratios. And now the last thing we need to do, we need to figure out the missing side on our triangle. And by Pythagorean theorem, we'd have, say, 2 squared plus x squared is 3 squared. And see, 9 minus 4, we're going to get a root 5 here, it looks like. And once we have all three sides, I can find the other trig function. So cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Then we have the reciprocals. Secant would be 3 over root 5. Cotangent would be root 5 over 2. And lastly, cosecant is the reciprocal of our sine, is 3 over 2.